So this is from the paper 2. So we're given that the coefficient of x to the power of 6 of this expansion is 448. Coefficient of x to the power of 6 of this expansion is 2880. We got to find a and b. So the general term of a binomial expansion always looks like this. Okay. So in the sense that if you have a plus b to the power of n, every term will have this kind of form. Okay. So the question is, which which number term of this guy will have x to the power of 6 in it? That's the question. So simple. First, 8 choose something. I don't know what that something is yet. Times the first thing, ax cubed to the power of something. I again don't know what that is yet. Times b to the power of something that I don't know what it is yet. Now remember that this guy and this guy are always the same, right? Like for
Yeah.
example, if you pick 3 here, you will have 3 here. And if you pick 3 here, you will need to have 5 here because the other requirement is that they add up to the total power. Okay? So we can
Mm.
make many combinations like this. Like we can put 4 here, and then we'll have to put 4 here, and then we'll have to put 4 here because they have to add up to 8 and similar. But we have a requirement. We're specifically looking for the term that has x to the power of 6 in it. So tell me, what do I need to put here to get x to the power of 6 in this term? What power should I raise ax cubed to get x to the power of 6?
Two.
2, exactly, because when you raise x cubed to square, you'll make it x6. Okay, if this is 2, what should this be?
Uh, Six.
Exactly, because they have to add up to 8. And again, if this is 6, then what should this number be?
Also six.
Exactly. And we know that this is supposed to equal 448 x to the power of 6, because it says that the coefficient of x to the power of 6 is 448. Okay, that's me using the first statement given to us. Let's do a similar job for the second one. So, can you try to build the second one on your own?
Yeah. So, I mean, we start with 10C.
And we don't know what the bottom number is, and
Yeah,
we
we
put,
don't know what the bottom
yeah,
one. So it's AX to the power, yeah, to the power, also to the power of two.
exactly. What do I need to put here now?
Eight.
Exactly. And what should I put here?
Eight at the bottom also.
Exactly. So we have 2880 x to the power of 6. Now, basically, we need to clean these up so that we have two clean equations that we can solve simultaneously. What is 8 choose 6 first? Let's see. It is 28. So we have on the left side of this equation, we have 28 a square x6 b6 equals 448 x6. And over here I have 10 choose 8, which is 10 choose 8, which is 45. So we have 45 a square x6 b8 equals 2880 x to the power of 6. Before we do anything, let's clean these equations up individually. The x6's can cancel out. Okay,
Mm-hmm.
so now we have 28 a square b6 equals 448. And we have 45 a square b8 equals 2880. I can divide both sides, just remove the 28 and the 45 from the left side. So we have 448 divided by 28, which is 16. And over here we have 2880 divided by 45, sorry, which is 64. And from here, there's a bunch of possibilities. My favorite way to solve this would be to divide both equations from each other. So I do a square b6 over a square b8 equals 16 over 64. The a squares cancel out. The b6 and the b8 cancel out to give you 1 over b square. And 16 over 64, I don't think you can simplify it much. Yeah, you only end up with 1 over 4. Following so far?
Yeah. Yeah.
And then you
Yeah.
can flip both sides, which gives you b squared equals 4, which means that b has to be equal to plus or minus 2. Remember that this rule for binomial expansion only works for, no, actually both of them are possible. So b can be plus or minus 2. Makes sense. Now what I was going to say is that the powers can only be positive numbers, but we're not talking about the power, we're talking about b. So b can be plus or minus 2.
Plus or minus, yeah, because it
Yeah.
doesn't. Yeah.
And since b is given as plus or minus 2, we can plug it into any one of these two equations to get a. So a squared times plus or minus 2 to the power of 8 equals 64. So regardless of whether it's plus or minus, to the power of 8 will make it positive anyway. Doesn't matter. 64 divided by 2 to the power of 8 gives me 1 over 4 again. A squared is 1 over 4, which means A is plus or minus 1 over 2. So any combination of this works. So you could have 1 over 2 x cubed plus 2 to the power of 8. You could have 1 over 2, sorry, minus 1 over 2 x cubed plus 2 to the power of 8. This is by the way, me just explaining it. It's not important.
Yeah, 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 I
This
know.
is your answer. So basically, any combination of plus minus 1 over 2 with plus minus 2 will work. That's your answer. So these questions are very easy if you can set up the skeleton. Okay. This is really the game changer. If you can just set up the skeleton in the kind of the sequence I showed you, it makes life very easy with all binomial theorem questions. By the way, they ask for positive versions of A and B, so we can only take the
The
A is
plus.
1 over 2. Yeah. So be careful. If you didn't write that down, you will lose a point for no reason. Just 1 point, but you would lose it. So it's not worth it. That's the end of this question. Any questions about this?
No, actually, no. That was like
Yeah.
pretty.
Yeah, it's honestly very easy question. I mean, once you get this, you're basically done.